Okay, so we are ready for the last presentation for today. Our speaker is Tobias and his topic is backup of scale, Bareos Active Client and Puppet.
Yes, thank you. I want to welcome you all to my little talk about my approach to upscale the Bareos backup and the configuration of our backup system. So, I want to give you first a little introduction, our environment, what we are using, and what we want from our new setup. Then I want to show you something about networking with Bareos. So the client modes which are already there in the latest stable release and which is now coming into the next stable release. Also, what does these clients mode mean if you have different kind of network setups? My second part of the presentation will be about our configuration management. We are using Puppet, trocla, and Hyra in a combination, and I hope I can give you a little bit how you can use it in your own company too. At the end, I will show you a short conclusion, what we did before we had the new system and what we do know now, and how much time it consumes. So, first about me, I'm 22 years old and I work exactly 1 year for GlobalWays as a Linux system engineer. I graduated last year with my bachelor's degree, and at GlobalWays I'm unofficially the chief backup officer. If you want to contact me, you can use this email address. So, what is the GlobalWays, or what does the GlobalWays do? We are an ISP in Stuttgart. We have 3 data centers at the moment, and we have a large fiber network in Stuttgart. We also do, for some customers, project hosting for virtual machines, mainly web hosting. This is also where our main environment for the backup is. We have many private customer networks, so local area networks, and Puppet setup with a 95% plus coverage. Also, we have a large Ceph cluster, about 2 petabytes, excuse me, where we can store our backups. And we use mainly virtualized machines. So, now what are our goals of a new Bareos setup? We don't want to use port forwarding anymore. When I started at GlobalWays a year before, we had a backup system with Bacula, and to reach the many clients in the private networks, we had to configure many port forwardings to reach them from our central Bacula director. Yes, we want a zero configuration backup, so we can just put a new server, new virtualized machine into our system, and it is daily backup with the default settings. Yes, we also want to use transport encryption, because why not? If it's possible, one should do the encryption, I think. And of course, we want to do all fully Puppet managed to get even the coverage even higher. So, let's talk about the first part, the networking. This is how the standard client of Bareos and Bacula basically behaves. The default mode says the director, or the scheduler of the director tells the director backup of a client should be done now, and the director connects to the address which is specified for the given client and the given port. So An arrow here means this is the direction in which the communication is initiated. This is something we need to know when firewalling networks. If you think of this client here in a private network and a firewall here, and these are some central machines, for this connection we have to provide a port forwarding at the firewall here. So the connection between the director and the storage daemon is here just for to be complete. This is actually can be ignored because these machines are mainly in the same network or already are on the same host. So to send the data from the file daemon to the storage daemon, the file daemon initiates a connection to the storage daemon and pushes the data over this connection. With this connection, we don't need any port forwardings at the firewall, only it has to be allowed to be opened a connection from this local area network to the central server. So what are the pros of this system? It is a simple configuration. It is the default mode, and yes, it's already there if we don't change anything. So this was not enough for some clients of Bareos, for some customers, and because of this, the passive mode was introduced in Bareos 13.2. Now this is a little bit different from how we wanted the setup to be. Now both the direct and the storage daemon initiates the connection to the file daemon. So we still need a port forwarding at the firewall here, but the client doesn't need to have any information about the director connection, the direct IP address or the storage IP address. So this have some pros. As I said, the client doesn't need any DNS or IPs of the servers, and the firewall can be the client can be firewalled completely. You can configure this in the client section of the director config if you specify the client with the key passive and the value yes. So what we wanted is an active client, and this is what we founded Bareos to introduce into the next stable release 16.2. This time the control channel is initiated from the file daemon to the director, and the data channel is also initiated from the file daemon to the storage daemon. So neither director nor storage daemon doesn't or have to know a little bit of the address or port or whatever of the file daemon. The file daemon connects when it starts to the director, and the director uses the open connection to send the execute, run a backup, for example, or run a script to back up the database or something like this. So this can be configured if in the client part of the director configuration, this key with the value yes is given, and when in the director part of the client configuration, also this key with the value yes is given. Okay. So the pros are, as I said, director and SD needs no knowledge about the client. The director and SD also needs no DNS. That's not really a pro, but it's possible to do. And if a firewall is here, no port forwarding is needed. So let's have a look at some simple network constructs. This is really simple. We have a local area network, and all hosts and servers are in the same network. Below here we see some clients, Bareos file daemons on a database server, on a desktop, on a mail server, and so on. And this Bareos server just stands for a director and a storage daemon on the same machine. So with this network, every client mode which I presented before is usable. In this case, the default mode has the least configuration needed and is to be preferred here, I think. So let's take this further. Now we have 2 times the simple network configuration, but instead of 2 Bareos servers, we have 1 Bareos server, and this is central. Between the Bareos server and the customer networks, for example, is a firewall, and which would need port forwarding again for standard and passive mode. So for this exact setup, to reach from the Bareos server to the clients, to the Bareos file daemons, you would need 4 port forwardings for this and 4 port forwardings for this network. With the active client, you don't need any port forwardings because the client is initiating the connection to the Bareos server. So let's take this another step further. Now we have N networks, all the same in this picture. And now the standard and the passive mode are not really suitable anymore. Now you would have to configure for this N networks the firewall with 4 port forwardings. And if you want to add a client to the customer 1 network, you have to go to the firewall of the customer 1 network and add another port forwarding. This is not really doable. So this is where active client really comes to get really good, because, again, 0 port forwardings needed. This is a network setup we don't really use, but it's possible with active client, and it is not possible with standard or passive client. Let's think of the internet, for example. So with active client, you can use backups over the internet if you have a stable TCP connection. And with standard and default mode, this is not really possible, except you have a virtual private network, for example. But please use transport encryption and verify peer when using unknown networks. This is really important. Okay, so short sum up. We have the simple network with the 3 client modes. All is good. We don't need any port forwardings. So we have 2 networks, and M is the number of clients per network. We have 2 multiplied with M port forwardings needed for standard and passive, and 0 for active. Now we have N networks, and we get N multiplied with M for standard and passive, but 0 for active. And now the interesting part again, you have an unknown network, and you can do this with standard or passive mode. But with active, no port forwarding needed. So let's recap our goals. We don't need any port forwarding anymore with Bareos active client. But still, 3 points missing. So the configuration part, it's done with Puppet. I will give you a short example of the Puppet language and how we use it. Puppet is an agent master architecture, or how we use it as an agent master architecture. This means the agent collects facts about the hardware it is running on or the system it is running on. So a fact can be, for example, the number of processors or the amount of RAM or something like this. This is sent to the master. The master has his own code base, which is programmed by the administrator with the Puppet language. And this master takes the facts and the code base and compiles this into a catalog. A catalog is a collection of running some jobs which can be done on the agent. This catalog is then sent back to the agent, and the agent runs the jobs in the catalog, and the configuration is done. There's one special thing. You can also do some exported resources, which I will show you in a few slides for what it is for. So, modules, as said in the other talk, are a generalized collection of code. Normally, you have only one purpose per module, and the most time these modules are on Puppet Forge. So forge.puppet.com. There is, as of now, not really a good usable Bareos module there. There is a module for Bacula from last updated, I think, 2013, and a module which do some of the configuration of Bareos, which is actually updated, but only runs on CentOS as far as I've seen. So I have written my own module earlier this year. This can install, configure, and manage the director, the storage daemon, the file daemon, the web UI, the B console. Yes, I think this was all. And it can do a complete mapping of the configuration. So if you go through the doc.bareos.org and look for the different key and values you can put in the configuration files, all this can be done with this module. It actually only runs on Ubuntu and Debian because we only use Ubuntu and Debian. We use Ubuntu servers. And it is not published yet. I plan to publish later this year when we are doing some more testing, which is required for a really good Puppet Forge contribution. So, short about Puppet language. This is how a class can look like. This class is for installing Bareos file daemon. So this is obviously called the Bareos file daemon install class. And if it is configured in the module to be installing a file daemon, this is this variable, it installs a package which name is in this variable, what is per default Bareos -fd, and it is installed with the ensure value, which is saved in this variable, which is per default latest, I think. This means the latest version of the Bareos FD is installed, which is in the package repositories of this system. The package the package type over here is a default type of Puppet, and it chooses the right backend depending on the system the agent is running. So this package type is a defined type. One can define different types which are behaving like a class. This is to configure the an auto changer of the storage daemon. You can configure multiple auto changers, and because of this, it is a defined type and not a class. So if you go to doc.bareos.org, you see the device, the changer command, and the changer device are mandatory parameters for this configuration. And as this is mandatory, there is no default value for this parameter. So the description is the only non-mandatory parameter, and the default value is only undef. This is another part. of Puppet language I want to show you. The concat module just collects fragments and concats them and saves them into files on the file system. So with this module, we can easily build something like the Bareos configuration in the old way or in the new way. This module uses them in the old way because when I have written this module, there has not been the new way already there. So the target here is in which file it is to be stored, and this is already etc Bareos / Bareos -sd.conf. So this configuration, what is done here, is pushed directly into the storage theme configuration file. The content comes from this template, which is this here. This is an embedded Ruby template, which just puts the variable contents into this file. And the description over here is optional. Okay. A really important part about this whole setup is the exported resources. With exported resources, I can compile or I can create a fragment of a concat on the client, which is then not necessarily applied on the client. I can upload this concat fragment to the server, which is stored then in the Puppet DB. One can ask, what do I do with this concat fragment in the Puppet DB? On the server side, or on the Bareos director side, I can use this collect resource statement to get all the exported resource from all clients with this tag and write them to the file system of the director. So I can run the Puppet agent on the client, the config, which is meant for the director to speak to the client, is then uploaded to the Puppet DB. And when the director Puppet agent runs, the exported resources are collected and then saved to the file system of the director, and the director is automatically reloaded and knows everything about the client, what he needs to know. So these are modules. Profiles are something in Puppet, or in a Puppet concept, is a wrapper about around modules. It basically contains the defaults for a corporation-wide setup. So I can publish a module on Puppet Forge, but keep everything what is special on our corporation setup in a profile. For example, global ways minus profile, Bareos. In profile Bareos client, which we see in a few slides, there are the defaults stored for the clients. This profile also provides a cron job for truncating all backups, because we are using file backups in which file name, the date of when it is created is stored. And so we have to truncate the old backups when we write new ones. The SAPIX monitoring is also configured, and it creates one MySQL catalog per customer. So every catalog is relatively small. This is not going to be published because this is specific job things only for our company. So with the module and the profile, we can check another entry of the goals list. It can now all be fully Puppet managed. But there are two other goals which we still have to reach. One goal can be reached with Trocla. Trocla is a password store which has a really nice integration into Puppet. Trocla uses a Moneta backend. Moneta backend is a normal key value backend. For example, you can use Postgres or something like this. This is how you can basically put a password into a Bareos, into a Puppet code. You can invocate the method trocla with a first parameter, which is the key of the key values, what the key value store is using. And the second parameter is what type of value we want to save or we want to get. A plain value is something like a password. So the third parameter of this is just a modification of the format. We want a plain password with the length of 63, and the char set should be alphanumeric. Every time we invocate this method, the same password is given back. And if there is no password in the key value store with this key, then a new value for this key is going to be generated. Okay, so are the passwords for the client and the director configuration done, but the main thing are the certificates. Trocla also can create a new certificate authority, for example. We use this so that every director gets a new certificate authority, and the clients can say which CA they want to use. And if this key is in Trocla, and it is an X509, then this value from this key will be used to sign this new certificate for the client. So with some easy steps, we get a new certificate authority for each director, and each client and storage daemon and so on, which connects on bconsole and so on, which connects to the director, gets a signed certificate and key from Puppet just into the file system where it can be used. A moment, please. We are using 3 directors. He asked how many directors we are using, and it is we are using 3 directors at the moment. Yes. Okay. Yes, this is basically how we can use Trocla and how we use Trocla to distribute a complete certificate authority and all certs and keys required to do our setup. Transport encryption is now easily done. You can use these keys also for data encryption and so on, but this is on your side. So the last part, the serial configuration backup I talked about, there we can use this project called Hyra. This is a simple key value lookup tool for Puppet. It is used to store the client configuration in JSON or YAML, for example. And it can merge a file configuration hierarchy. So that if I have a common.yaml for a customer, and I have other YAML files, each for one client, the default setup can be done in the common YAML, and everything that is client-specific can be done in the YAML specific for this client. Okay, what has to be done to back up a client in this new setup? This line has to be added to the classes variable in the YAML file. It is just one entry. And if this entry is in the common YAML for a customer, and we add a new client or a new Puppet agent into the environment of the customer, we don't even need this entry anymore. So this is a zero configuration backup of this new client. Okay, what does this do in the background? It installs file daemon, it configures with the default director, which is the director for the customers. It creates the SSL certificates, it delivers all the database backup scripts we use. It exports the config, which is then used to import into the director automatically. And it configures the monitoring server to look if the backup is done on a daily basis. The configuration on the server side is a little bit more difficult because we don't have hundreds of directors, and we don't have to have hundreds of directors which are the same. So here we basically include this class, and I shortcutted it here a little bit to have it all on the slides. Yes, we get a director tag, which is used to identify which director the client belongs to, and the storage daemon tag to identify to which storage daemon the backup should go. Okay, the mount point is again server specific because we do file backups into a mount point where our Ceph cluster, or a Radis block device from our Ceph cluster, is mounted. And we give them a specific amount of devices which should be virtually generated in there. We also give here a little list of catalogs we need. This is an example for a customer ID. On our servers, there's a long list of customers' ID, and for each, there is a catalog generated. And we can also add in this YAML file for clients which are not Puppet managed, non-Puppet managed clients to the Bareos director. For this setup, it is the certificate and so on is naturally not really working. We have to place it manually on the server and configure it manually, what is quite a pain. Okay. Now our goals. We have all met everyone. So the conclusion is we have the old way of do backup configuration. This is issue a new certificate, install the client and configure it, and then do a firewall port forwarding, then do a director config, and config the monitoring also. The inverted boxes here and over here are things which can only be done by specific colleagues, and also requires communication between people. Communication between people is really difficult sometimes, and I think it is really simpler to just add a server into Puppet and give him the Bareos profile Bareos client class, and everything else is done automatically. So, thank you for attention. This is it. Any questions?
Yeah, here's one. One moment.
Maybe somewhat off topic, but why did you choose to have a special CA for Bareos when you can reuse the Puppet certificates?
Because we don't want to change the Bareos CA when we have to change the Puppet CA. And with trocla, we already use trocla, and it is really easy to generate a new CA. And so we just did it. And So we also have the possibility to generate certificates easily, which are for clients which are not in Puppet. So we can generate the certificate and copy it manually to the client, to the Bareos FD, and then configure it there.
Okay, thanks.
Okay, no more at this time.
So you did say, so I have two questions. First one, you did say that you can configure every configuration, you can set every configuration option. You really support all options, or is this handled manually, or how have you implemented this?
I support all options which are in the doc.bareos.org to the time I've programmed this. It is not so that you can give any key value to this module and it will just write it into the files. It will validate if it if the key is existing, and if the value for some configuration parameters, it also looks if the value is in the right type of variable. Versioning is something which can be done so that in the logic you can look if there is going to be 16.2 installed, and it looks whether the configuration parameters exist in 16.2 or not, and gives a failure if not. Yes. So the whole configuration and what can be done is implemented, but it's statically implemented. So I have to extend it if there are new features.
Okay. I just like to point out, maybe you're already aware of this, that you can get a list in JSON format of all the configuration options from each daemon by starting the daemon with -x s export schema, and then you also get the default values and things like this.
Yes, this is a possibility how we can achieve in the future to be capable of getting different versions and different configuration parameters into the module. Yes. Okay, thank you.
And another question, if I am allowed. I find it quite interesting that Christians has taken a quite different approach for scaling, and you have taken the approach with using one catalog per client, and also we have talked about this yesterday. Have a set of devices and set a device for backup job or for a client. Maybe you can tell us a bit about this in a few sentences, because I think it's maybe of interest also for other people.
Yes, I will get back into this with him later, I think, or via email. But the interesting part is we both use MySQL to store the catalog, and in the past we got really fast into performance problems with large catalogs. I think one part of this is eventually that he's using a hardware machine with 8 cores and lots of RAM in comparison to the virtual machines we are using as director and storage daemon. We are using generally about 4 cores, 4 virtual cores, and I think 8 gigabytes of RAM to run the directors and the storage daemon, which is enough for us. They also get 10 gigabits into the virtualized hardware, so to the customers, and 10 gigabits to the Ceph cluster, so they can write the storage back. Yes, we have to look why the catalogs are so slow for us when we save them all in one. Yes. Okay, any questions? Yes?
Yes, one moment. Give my best.
Just one quick question. How do I see you're using concatenate as to combine all the configuration for all the clients? Yes. How do you actually handle removed or deleting clients?
This is quite interesting. We have the Bareos conf, and in this Bareos conf we have the syntax with an add, and then you can add a path behind the add, and it is included into the config. So we just roll out the client configs into the Bareos -dir.d directory, and they will never be deleted there. This is not purged. But what is deleted is the line in the Bareos configuration file, which includes this configuration. So if anytime anything fails, and this line is deleted, is actually really manually, really easy manually added in, and you can perform a restore or something like this for this client.
Okay, thank you.
So I think no more questions.
No more questions then. Thank you.